Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's take a look at our homework for lesson 8.3.1. First off, we were learning, and you were introduced actually to functions today. We're going to learn more about it in part 2 of the lesson. A relationship between input and output is a function if there is no more than one input for each output. Okay, so you may have noticed throughout the school year that I've referred to this formula, y equals mx plus b, slope-intercept form of linear functions. I go back and forth between linear functions, linear rules, linear equations. Equations are equations, but not all equations are functions. Functions can be written as an equation, like for instance, this is an example of one where every input, here is your input variable, produces exactly one output. And so everything we've been working with so far this year have been functions. So when you plug in a value for x, like -2, into this equation, -2 minus 2 is -4, and -4 squared gives you positive 16. Every time you plug actually, hold on, change color back. Every time you plug in an input into this rule, you will get exactly this output. If you ever put a -2 into this rule and you don't get a 16, something is wrong. Something is broken, and it would be actually impossible in this situation. So that's the nature of functions. Every time you plug in a number for x, you will always get the same output, the same value for y. Okay. And so here's an example of a function, and I'm not quite sure exactly where we talk about specifically this rule, but there is, when I was in high school, there was what we called the vertical line test or the vertical pencil test, because often that was the only line that we had available to us while sitting at our desk in math class. And after you've created your graph, if you hold this vertical line over your graph, if there's ever more than one point on that line, right? All of these are a collection of points making this U-shaped parabola. If there's ever more than one point on there, it would not be considered a function. So when you come to this circle is not an example of a function. Yes, there's a rule that applies for this. In fact, there's an even fancier rule here that you'll learn about in high school. But just because there's a rule or an equation doesn't make it a function. So notice our what we set up here. Every value for x should produce exactly one output for y. Well, notice here that the 0 for x gave you a -1 one time, but it also gave you a +1. So you got two different values for y, same input value for x, making it, I'm sorry, did I say that? You got a different value for y than I'm tired. Okay, try and say this one more time. The same value for x produced two different outputs. That breaks the rules. This is not considered a function here. And then the vertical line test shows it's a function because here you've got, let's do this. You got a value there and a value there. Two different points from your circle fall on the vertical line. Not a function. Okay, so when you get into high school, 9th grade, you are going to deal a lot with functions. I am just introducing the idea to you in chapter 8 toward the end of 8th grade, but you will get much deeper into it. So let's get on to it. All right, so here are what we call like function machines, where you've got an input value that goes into your function, and then you work through the process to create an output. So when you put the 8 in, the absolute value of 8 is 8, so your output would be 8. In this case, you have to plug in a number, and after working through the sequence, you get 2 for an answer. So what was that number initially? Well, let's go ahead and actually let me change that to a different color so it stands out. So we're going to say that 2 is equal to 3 minus the absolute value for x. So what we need to do here is let's subtract 3 from each side. and that gives us -1 is equal to the opposite of the absolute value of x. And I don't like having this negative sign on the outside. That means multiply whatever the absolute value of x times -1. So if I divide both sides by -1, this becomes 1 is equal to the absolute value of x. So notice our obvious answer would be 1, right? Because the absolute value of 1 is 1. But there's also another solution where x could be -1 because the absolute value of -1 is also 1. So there's actually two solutions that work, or two values for x that will produce this output for y. Let's put it that way. Here we're dealing with a different input variable, but it doesn't make any difference. K is equal to -6, so we put it into the function. -6 divided by 2 is -3, and -3 plus 1 gives you -2. So your output is -2. And in this case, we're going to plug in the 3, and we're going to take the opposite of whatever 3 squared is. So we have to do the exponent first because order of operations requires us to do exponents before we multiply. And when you take the opposite of a number, you're multiplying times -1. So we're going to do this, and then that becomes the opposite of 9, which is -9. Okay, so function machines are just a different way of kind of talking about, okay, well, here's a rule. Here's your value for x. Find out what y is. Or here's your value for y. Find out what x is. Compute each product or quotient. Convert the final answer to scientific notation if necessary. Okay, so in this case, we're going to start by multiplying the leading digits together first, and then the powers of 10 together. And then we see 24 times 10 to the 7th, but that's not scientific notation because this number is supposed to be 0.4, or a number between 1 and 10, right? So there's two ways to do this. You can either borrow a power of 10 from this and move it over to here. So you're essentially dividing that by 10 to get 2.4, but then you move that 10 into here and add it to the 10 to the 7th becomes 10 to the 8th. Did I say added? I mean add the exponents because you're doing this, right? Multiplying powers with the same base. You keep your base, you add your exponents. Another way to do it would be this. 10 to the 7th power, 1, 2, 3, 4, 5, 6, 7, is 10 million. So if I multiply 24 times 10 million, I get 240 million. And then you identify the leading digit is the 2. What place is the 2 in? It's in the 100 millions place. So 100 million has 1, 2, 3, 4, 5, 6, 7, 8 zeros. So that's another way that you could show, going into standard form and then back into scientific notation, how to change this so that it's appropriately written in scientific notation. Same thing applies here. You're going to take 14 and take the 10, the power of 10 from that, so it becomes 1.4 times 10 to the first times 10 to the -10th. And now we're going to keep our base and we're going to add the exponents. 1 plus -10 equals -9. Students are going to say -11 here if they don't work through the process. I highly encourage you to show work whenever possible so you don't lose track of steps and you don't make any simple mistakes. And then this one is pretty straightforward. 9 divided by 4 is 2.25, so that's already a number between 1 and 10. You don't have to adjust that. And then 5 minus 7 is -2, so this becomes 2.25 times 10 to the -2nd power. Solving equations. It says solve each one of these for x. So two of them have just the one variable. These two have two variables. So you're going to have to get the x all by itself on one side, and then your y term and your constant term by itself on this side. So let me actually, I think you guys know how to do these. I'm going to do these two. Okay, so start with this one. We're going to send in the dive bomber, so that becomes 2x minus 12 is equal to y minus 14. And now we've got to get these x's by themselves. So let's add 12 to each side, giving you 2x's is equal to y minus 2. And now when we divide everything by 2, you'll just have the 1x there. But now you could write it as y divided by 2, 1/2 times y, or technically you could have done this as well. That would be another way to write this. And then for this guy, what are we solving for? Still? Okay, so 3/4 of y is equal to 2x minus 6. We better add 6 to each side. And I don't like, we're going to have to take 6 plus 3/4 of y is equal to 2x. Now we are going to have to divide this by 2. This is easy to divide by 2. 6 divided by 2 is 3. Got it. But this is turning into a complex fraction. So let me actually do something here. Let me get rid of all this work so I have room to show this. This is telling you to take 3/4 and divide it by 2. 3/4 divided by 2 is the same as 3/4 times 1/2. And that gives you 3/8 for your answer. So you get your 3, you got your 3/8. That's not a negative 3/8, it's just a 3/8 times y, and then you got your x all by itself. Doesn't really matter that whether you have the x on the left side or on the right side, the expression 3 plus 3/8 of y or 3/8 of y plus 3y can be rearranged. All right, find the rule for this situation. Well, it's nice that they gave us this because that's our y-intercept. What we need to do is take two of the known ordered pairs and figure out what the slope ratio is between them. So remember, we're taking the change in y over the change in x. So it doesn't really matter which direction you go in. If we go from here, the change in y is increasing by 2, and the change in x is increasing by 3, so your slope is going to be 2/3. But if you started with this one, you go 4, you go down 2, that's a negative 2, and this one, 0 minus 3, you go down 3. You've got two negatives, and whenever you've got a fraction with two negatives, they cancel each other out to make it positive. So definitely y equals 2/3 of x plus 2. The slope is 2/3. So is this an example of linear or nonlinear growth? This, because it's y equals mx plus b, is linear growth, and there is a constant growth rate. Every time x increases by 3, y increases by 2. That's what this growth rate is right there. All right, the two triangles at the right are similar to each other. What is the scale factor between these two? All right, so let's take a look at the known sides. The shortest side here is 8. The shortest side there is 20. So we're going to write that as a ratio, 20 over 8 or 8 over 20. Let's simplify these. I think they have 4 in common, so this becomes 2 over 5, and this becomes 5 over 2. So those would be your two slope ratios, and technically the scale factor going from A to B is 2.5, but I would prefer that we actually write it this way so that you can go in either direction. Okay, so find the missing sides. One of the hardest things about this is making sure you get the corresponding sides together. The longest side here is 16, the longest side here is t. So those two correspond to each other, and this medium side here and this medium side here go together as well. So how do we solve for s? To solve for s, we're going to multiply 35 times the scale factor that's going to make it smaller. So this is going to be 35 over 1 times 2 over 5, which is 70 over 5, which is equal to 14. So s has to be equal to 14. And that makes sense, right? Because s is a length between 8 and 16. That's the shortest, that's the longest. 14 falls between there. That makes sense. Now let's solve for t. T is the shorter, or is the longer one. So t is going to be equal to what you get when you take 16 and you multiply times the scale factor. That's going to shrink it. No, it's not. Yes, it is. Yes. Yes. T is going to be, no. No. T is bigger than 16, isn't it? So we need to take our known number, 16, and then make it bigger. So yes, we're going to do 5 over 2. My bad. I'm glad I thought that through. Okay, so that becomes 80 over 2, which is equal to 40. That's the length of 40. So if you wanted to make a shape smaller instead of bigger, what is the scale factor you would use? You would use this one right there, the one that is between 0 and 1. All right, Anthony has added a trend line to the scatter plot. Do you agree with where he put it? And his is the black one. I just don't feel like that really follows the trend, and there isn't a balance. See how far away these guys are compared to those? You want it to run through the middle, and you want it to follow the trend. So I think the red line is probably a better line of best fit than the black one. But this is the thing, is when you start getting a really weak association, it becomes harder and harder and harder to find that line of best fit. If I add those 5 points, this turns the entire scatter plot into a no association situation. So it is just barely a negative association. It's very, very weak. So it's not easy to figure out exactly where your line should go. And that is it. We are done with today's homework. All right, let's move on to the next activity. Here.
Hey, feeling good, like I should. When in dark, I walk around the neighborhood. Feeling blessed,